everyone, welcome back to my channel. In this video, we are going to study about Clairaut's equation and reducible to Clairaut's equation. First, let us understand what do you mean by Clairaut's equation. An equation of the form y is equal to p of x plus f of p, where p is equal to dy by dx and f of p is a function of p only, is called Clairaut's equation. So, an equation of the form y is equal to p of x plus f of p, where p is dy by dx, we already know p is a dy by dx, and f of p is a function of p only. Here, f of p is a function of p, is called Clairaut's form of equation. Call this as equation number 1. So, an equation of the form y is equal to p of x plus f of p is a Clairaut's equation. Let's see what is the working rule to find the general solution of nonlinear differential equation with the help of Clairaut's form of equation. First step, here they will give a nonlinear differential equation or directly a Clairaut's equation of the form y is equal to p of x plus f of p. In the first step, they will give a nonlinear differential equation. If they give a nonlinear differential equation, we have to reduce this to a Clairaut's form of equation, that is y is equal to p of x plus f of p. Once we obtain the Clairaut's form of equation, the general solution of a Clairaut's equation is obtained by replacing here in the place of p, we have to replace it by c, where c is a constant. So if we replace in the place of p as c, we get a general solution of a Clairaut's equation. That's the second step. Here, if in the given problem they ask to find a general solution of a Clairaut's equation, means first you have to obtain a Clairaut's equation, that is of the form y is equal to p of x plus f of p. Once you obtain the Clairaut's equation, we have to replace in the place of p as c, we get a general solution for a Clairaut's equation. In continuation of this, if they ask to find a general solution and to find a singular solution also, in that case, to obtain a singular solution, differentiate the given equation partially with respect to p, we get here, if you obtain Clairaut's equation, to find the general solution means you have to substitute in the place of p as c. Again, also they ask to find a singular solution means you have to differentiate this Clairaut's equation partially with respect to p. Once you obtain the partial differentiation of Clairaut's equation with respect to p, finally we get an equation of the form, if we differentiate this equation partially with respect to p, means we get an equation of the form 0 is equal to x plus f dash of p. Here this is a partial differentiation of this function, that is f dash of p. In the last step, we have to eliminate p between the given problem, by thus obtain the result. Here the general solution means we have to replace in the place of Clairaut's equation p as c. Once you obtain the general solution, to obtain the singular solution, we have to differentiate this Clairaut's equation with respect to p partially. We get an equation of the form 0 is equal to x plus f dash of p. Finally, to find the singular solution means you have to replace or we have to eliminate p in the obtained equation. For that, we have to consider these two equations and find the value of p and substitute in the obtained or a given Clairaut's equation. We get a singular solution for a Clairaut's equation. This is a working procedure to find the general solution and singular solution of a Clairaut's equation. Let's solve some problems so that you can understand in a better way. Here is the first problem. Solve the equation xp square minus yp plus a, which is equal to 0. Also find its singular solution. First, take the given data. Here, for this nonlinear differential equation, we have to solve this nonlinear differential equation, and also we have to find the singular solution for this nonlinear differential equation. Here, to find the singular solution means first you have to achieve Clairaut's form of equation. That is, we have to find the Clairaut's form of equation with the help of this nonlinear differential equation. We know that Clairaut's form of equation is given by y is equal to p of x plus f of p. To achieve that Clairaut's form of equation, take this yp to the right hand side, we get yp which is equal to xp square plus a as it is. Next step, take this p to the right hand side, we get y is equal to xp square plus a divided by p. Here in the right hand side we can split it as xp square by p plus a by p, so that we get y is equal to here xp square by p, here pp gets cancelled, remaining is xp plus a divided by p. Call this as equation number 1. Now equation 1 is of the form y is equal to p of x plus f of p. Here first function is a function of p and x, but second function is a function of p only. Here a is some constant. So equation 1, that is y is equal to xp plus a by p, is of the form y is equal to p of x plus f of p. Hence we can conclude equation 1 is a Clairaut's form of equation. Once we obtain a Clairaut's form of equation, first step we have to find the general solution for this Clairaut's form of equation. For that, replace in the place of p as c in equation number 1, we get the general solution of a given differential equation, that is y is equal to, in the place of p we have to replace by c, we get as y is equal to cx plus a divided by c. Once we obtain the general solution, to find the singular solution, we have to differentiate equation 1 partially with respect to p. We get equation 1 is y is equal to xp plus a by p. If we differentiate this equation 1 partially with respect to p, we get here this is a constant. So differentiation of this is 0, which is equal to here x is constant, take as it is, into differentiation of p is 1 plus a is constant into differentiation of 1 by p is minus 1 by p square. That is 0 is equal to x plus into minus a by p square. Or we can take it as, if we take this value to the left hand side, that becomes a by p square, which is equal to x. If we take this p square to the right hand side and x goes to the left hand side, we get p square is equal to a by x, or we get a value of p as square root of a by x. So if we differentiate equation 1 partially with respect to p, we get a value of p, that is p is equal to square root of a by x. Once you obtain a value of p, we have to substitute this p value again for an equation 1. We get, that is substituting p value in equation 1, we get here equation 1 is y is equal to xp plus a by p. If we substitute p value over here, we get y is equal to, here p is square root of a by x into x plus a divided by p is square root of a by x. If we make the simplification, we get y is equal to, here we can split it as square root of a divided by square root of x into, here we can write x as square root of x into square root of x. If we multiply these two value, we get a value of x itself, plus here also if we take a as square root of a into square root of a into, here this becomes square root of a divided by square root of x, that becomes square root x goes to the numerator, we get as square root x divided by square root a, so that we can cancel this square root x and square root x here. Here we can cancel square root a and square root a. Remaining is here square root a into square root x, we can take it as square root a into x, plus here also square root a into square root x, we can take it as square root a into x. So if we add these two terms, we get a value of y as 2 into root ax. So y is equal to 2 into square root of ax is a singular solution for a given nonlinear differential equation. This completes the problem. Here we are doing this step, that means we have to differentiate equation 1 partially. Equation 1 is nothing but Clairaut's equation partially with respect to p. We get a value of p. Once we obtain a value of p, we can substitute this value in again in equation 1. We get a singular solution. That is, singular solution means an equation which does not contain a value p. This is a singular solution. This is a procedure to find the general solution and singular solution for a Clairaut's equation. Let's see some more problem. Here is a second problem. Solve the equation xp square plus xp minus yp plus 1 minus y, which is equal to 0. Here we have to find the general solution and singular solution for this equation. For that, take the given data first. Here observe the equation. Here we have xp square. Here we have xp term. Here we have minus yp. Here also we have y term. So we can do factor as, here if we take px as common over these two equation, we get px into, here remaining is p plus 1. Here if we take in these two value, we can take minus y as common, remaining is p plus 1, and take plus 1 to the right hand side, we get as, which is equal to minus 1. Next step, here also we have p plus 1, here also we have p plus 1, so that you can take p plus 1 as common over here. We get remaining is px minus y into p plus 1, which is equal to minus 1. Here our aim is to find a Clairaut's equation of the form y is equal to px plus f of p. For that we are doing this procedure. Next we can take px minus y into p plus 1, which is equal to minus 1. We can take p plus 1 to the right hand side, that becomes px minus y, which is equal to minus 1. This p plus 1 goes to the denominator, that is minus 1 divided by p plus 1. Again, to achieve the Clairaut's equation, take this minus y to the right hand side and this value goes to the left hand side. We get an equation y is equal to px. If we take this equation to the left hand side, that is plus 1 by p plus 1. Call this as equation 1. So we can clearly tell this is an equation of the form y is equal to px plus f of p. Therefore, we can conclude equation 1 is a Clairaut's equation. Here they will give a nonlinear differential equation. We convert this nonlinear differential equation to a Clairaut's equation first. This is a first step. Once you obtain the Clairaut's equation, it is easy to find the general solution of a Clairaut's equation. That is, we have to replace in the place of p as c, we get a value of general solution of a Clairaut's equation. That is, y is equal to, in the place of p as c means cx plus 1 by c plus 1. So this is a general solution. Next step, we have to find the singular solution for the Clairaut's equation. For that, we have to differentiate equation 1 partially with respect to p. We get, here in the left hand side side we get a 0, which is equal to, here x is constant, take as it is, into differentiation of p is 1 plus 1 by p plus 1. This is of the form 1 by x. So differentiation of 1 by x is minus 1 by x square. Similar way, differentiation of 1 by p plus 1 is minus 1 by p plus 1 whole square. Next step, take this value to the left hand side, we get 1 by p plus 1 whole square, which is equal to x. Take this value to the right hand side and x goes to the denominator, we get as p plus 1 whole square, which is equal to 1 by x. Or take this square to the right hand side, that becomes square root, that is p plus 1, which is equal to square root of 1 by x. Or we can take the value of p as, here we can split it as square root of 1 by square root of x. We know that square root of 1 is 1 itself. Therefore, we get value of p as 1 divided by square root of x minus 1. This is a value of p. Once we obtain the p value, next step we have to substitute this p value again in equation 1. We know that equation 1 is y is equal to xp plus 1 by p plus 1 whole square. Substitute p value over here and over here we get as y is equal to, here p is 1 by square root of x minus 1 into x as it is, plus 1 divided by p plus 1, that is p is square root of 1 by x minus 1 plus 1 whole square. Next step, multiply x inside the bracket here. Here also, here plus 1 minus 1 gets cancelled and simplify the value we get as y is equal to, here if we multiply this value we get x into 1 by root x is x by root x minus 1 into x is x. Here plus 1 minus 1 gets cancelled, remaining is square root of 1 by x whole square. Here square and 2 gets cancelled. This x goes to the numerator, we get as plus x. Here plus x minus x gets cancelled. Here we can split this x as square root of x into square root of x. 1 square root of x, 1 square root of gets cancelled. Therefore, we get a value of singular solution, that is y is equal to square root x. Here plus x minus x gets cancelled. We can split x as square root x into square root x, so that we can cancel this square root x and square root x. Remaining is root x. Therefore, y is equal to root x is a singular solution for a given nonlinear differential equation. This completes the problem. We shall move on to another type of problem. Find general and singular solution for x square into y minus px, which is equal to p square y, by taking Clairaut's form using substitution. X is equal to x square and y is equal to y square. Here this is another type of problem, that is reducible to Clairaut's form of equation. Here they will give a nonlinear differential equation. Here we have to reduce this nonlinear differential equation to a Clairaut's form of equation with the help of substitution. X is equal to x square and y is equal to y square. Let's see how to solve these type of problems. First, take the given data x square into y minus px, which is equal to p square y. Call this as equation 1. Also, they have given a substitution as capital X, which is equal to x square, and capital Y, which is equal to y square. Call this as equation number 2 and call this as equation number 3. Here, we have to solve this equation with the help of substitution. Means first step, we have to differentiate these two equations with respect to x and with respect to y separately. Here x is equal to x square means you have to differentiate this equation with respect to x. Here y is equal to y square means you have to differentiate this equation with respect to y. We get d into capital X divided by dx, which is equal to, here differentiation of x square is 2x. Similarly, d into capital Y divided by dy, which is equal to differentiation of y square is 2y. Next step, we have to take the value of small letter p. We know that p is equal to dy by dx. Here this is an important step. Here dy by dx, we can write it as dy divided by d into capital Y into d into capital Y divided by d into small letter x into d into capital X divided by d into small letter x. This is a very important step to be remembered. P is equal to dy by dx. We know dy by dx, we can split it as dy by dy into dy by dx into dx by dx. Here dy gets cancelled, dx gets cancelled, remaining is dy by dx itself. So this is a very important step. Here these two important steps you have to remember. Next, we have to substitute dy by dy and dx by dx value here. Here we know that d into capital X divided by dx is 2x. Here we have d into capital Y divided by dy. Here we have d into small letter y divided by dy. So that we have to reciprocal this value. We get dy by dy as 1 by 2y. Therefore, dy by dy is 1 by 2y into, here we know that small letter p is small letter of dy by dx. Therefore, we can write in the place of d into capital Y divided by d into capital X as some capital P into, here dx by dx is 2x. Here 2 gets cancelled. Remaining is p is equal to capital P into x divided by y. P is equal to capital P into x divided by y is remaining. Next step, once you obtain a small letter p value, From equation 2 and equation 3, we can write x and y in the form of capital X and capital Y as here small letter x is capital X is x square. If we take this square to the left hand side, that becomes small letter x is square root of a capital X and small letter y is square root of capital Y. So substitute here in the place of small letter y x and small letter y as root x and root y, we get as p is equal to capital P into square root of x by y. Here small letter p, which is equal to capital letters of p and x and y, that is small letter p is equal to p into root of x by y. Next step, we have to substitute this small letter p value in the given differential equation. We get here x square is x into here in the place of y we can substitute as root y minus p is capital P into square root of x by y into here small letter x is square root of x, which is equal to p square is p into square root of x by y whole square into small letter y is square root of capital Y. We have to substitute correctly x square y minus px, which is equal to p square y. We have to substitute all this value, p value and also small letter x and small letter y value. We get a value as like this. Next step, here root y minus p into here root x into root x, we can take it as x itself and split the root here. We get a value as x into root y minus p into here root x into root x is x, px divided by root y, which is equal to p square into here square root of x by y whole square. Square and root gets cancelled, remaining is x by y into root y. Next step, take the LCM as root y over here and here we can split this y as root y into root y, hence we can cancel this root y term. We get as x into here root y into root y is y minus px divided by root y, which is equal to here x into p square divided by root y. Here y can be split it as root y into root y, so that we can cancel this one root y and one root y, remaining is root y itself, hence we get x into p square by root y. Here also x by root y, here also x by root y, we can cancel these two values. We get y minus px, which is equal to p square. Y minus px, which is equal to p square. If we take this px to the right hand side, we get y is equal to plus px plus p square. So this is an equation of the form y is equal to p of x plus f of p. So we can conclude that this is a Clairaut's form of equation. Call this as equation number 4. Next step, once you obtain the Clairaut's equation, the general solution is given by the formula. We have to replace p by c over here. We get as y is equal to cx plus c square. Here we have to replace p by c. We get a general solution. Next step, we have to find the singular solution. For that, we have to differentiate this Clairaut's equation partially with respect to capital P. Here we get 0, which is equal to here x is constant, take as this into differentiation of capital P is 1 plus differentiation of p square is 2p, which implies here if we take this x to the left hand side, that becomes minus x, then 2 goes to the denominator, we get a value of p as minus x divided by 2. Here capital P is equal to minus capital X divided by 2. Substituting x values, that is capital values, here we get as p value as minus small letter x square divided by 2. Here minus, we know that x is x square, so substituting value we get a capital P value as minus x square divided by 2. That's the value of p. Next step, we have to substitute this capital P value over here. Also substituting x and y value over here, we get as here y is small letter y square, which is equal to p is minus x square by 2 into x is x square plus p square is minus x square by 2 whole square. Here we have minus x square into x square is x power 4 by 2, that is minus x power 4 by 2. Here this minus x square by 2 whole square, so minus sign becomes positive sign, hence you get plus x power 4 by 4, that is y square, which is equal to minus x power 4 by 2 plus here this is x square by 2 whole square, that is plus x power 4 by 4. Here if we take 4 as LCM and simplify, we get as y square, which is equal to minus x power 4 by 4. Take this 4 to the left hand side and this minus x power 4 also to the left hand side, we get as 4y square plus x power 4, which is equal to 0. So this is a singular solution for a given nonlinear differential equation. This completes the problem. These are all very important problems. Let's solve some more problems so that you can understand in a better way. Here is another problem. Find general and singular solution for px minus y into py plus x, which is equal to 2p, by taking Clairaut's form using substitution x is equal to x square and y is equal to y square. Here first we have to take the given data, that is px minus y into py plus x, which is equal to 2p. This is a given nonlinear differential equation. Call this as equation 1. Also they have given a substitution value as x is equal to x square and y is equal to y square. Call this as equation 2 and this as equation 3. Next step, we have to differentiate this equation 2 and equation 3 with respect to x and with respect to y, we get d into capital X by dx is differentiation of x square is 2x, d into capital Y by dy is differentiation of y square is 2y. Next step, we know that p we can split it as dy by dx, which is equal to dy by d into capital Y into d into capital Y by d into capital X into d into capital X divided by d into small x. If we cancel this dy term and dx term, remaining is dy by dx itself. Next step, substitute all these value. We know that d into capital Y by d into small y value is 2y, but here we have d into small y divided by d into capital Y. So we have to reciprocal this value, we get 1 by 2y into here d into capital Y by d into capital X is capital P into dx by dx is 2x. Here 2 gets cancelled. Remaining is p is equal to capital P into x by y. We know that x and y from equation 2 and equation 3 we can write it as x is equal to square root of capital X, y is square root of capital Y. Substituting this value here, we get small letter p is equal to capital P into square root of the small letter x is root x divided by root y. We can write it as square root of x by y. Next step, we have to substitute this p value in equation 1. Here equation 1 is this. Substituting all this value, we get as a small letter p is capital P into square root of x by y into here small x is root into capital X minus small y is root into capital Y into p is p into root of x by y into y is root of y plus x is root of capital X, which is equal to 2 into p is capital P into root of x by y. Next step, here we have to take root y as LCM. Here root x into root x is x itself. Here also we have to take as root y as LCM over here. We get as px minus y divided by root y into root of xy into p plus root of xy divided by root y, which is equal to 2 into, we can split off root of x by y as root x divided by root y into p. Here also root of xy, here also root of xy, we can take it as common. Remaining is xp minus y divided by root y into, here if we take as common as root of xy, remaining is p plus 1 divided by root y, which is equal to 2 into root x by root y into p. Here we can split this as root x into root y so that we can cancel the terms. That is here root x and here root x gets cancelled. Here root y and root y gets cancelled. Here also root y, here also root y gets cancelled. Remaining is xp minus y into p plus 1, which is equal to 2 into p. Next step, we have to take this p plus 1 to the right hand side. We get as xp minus y, which is equal to, here this goes to the denominator, that is 2p divided by p plus 1. Next step, take this value to the right hand side and all this value to the left hand side. We get a value of y as px plus of minus into 2p divided by p plus 1. Observing this equation, we can conclude that this is a Clairaut's form of equation, that is of the form y is equal to px plus f of p. Therefore, we can conclude this is a Clairaut's form of equation. Call this as equation number 4. Next step, once you obtain the Clairaut's form of equation, the general solution is given by, we have to substitute in the place of p as c. We get a general solution as y is equal to cx minus 2c divided by c plus 1. Once you obtain the general solution, the singular solution, to obtain the singular solution, we have to differentiate this equation 4 partially with respect to capital P. We get, here in the left hand side we get 0, which is equal to x is constant, take as it is, into differentiation of p is 1, plus into minus minus, here 2p is also function, p plus 1 is also function. Take quotient rule over here. We get denominator, that is p plus 1 into d by dp of numerator, that is differentiation of 2p is 2, minus numerator into differentiation of p plus 1 is 1 divided by denominator whole square, that is p plus 1 whole square. Here multiply 2 inside the bracket, we get as 0 is equal to x minus 2p plus 2 minus 2p divided by p plus 1 whole square. Here plus 2p minus 2p gets cancelled. Remaining is minus 2 divided by p plus 1 whole square. We take this value to the left hand side. We get a value of p plus 1 whole square as 2 divided by x. That is x is equal to 2 divided by p plus 1 whole square. That becomes p plus 1 whole square is equal to 2 divided by this x goes to the right hand side, that goes to the denominator, that is 2 divided by x. If we take this square to the right hand side, that becomes square root. We get as p plus 1, which is equal to square root of 2 by capital X, or we can take p as square root of 2 by capital X minus 1. This is a value of capital P. Once you obtain a value p, you have to substitute p value in equation 4. We get here equation number 4 is y is equal to px plus of minus 2p by p plus 1. Substitute p value over here. We get as y is equal to px, that is p is square root of 2 by x minus 1 into x minus 2 into p is square root of 2 by x minus 1 divided by p is square root of 2 by x minus 1 plus 1. Here minus 1 plus 1 gets cancelled. Take the LCM as square root x here. Here plus 1 minus 1 gets cancelled. Here also take the LCM as root x. We get as y is equal to here root 2 minus 1 into root x is root x divided by root x into x minus 2 into here root 2 minus root x into 1 is root x divided by divided by here plus 1 minus 1 gets cancelled, remaining is root 2 divided by root x. Here root x gets cancelled. Here we can split this 2 as root 2 into root 2. Therefore we can cancel this 1 root 2. Here also we can split x as root x into root x. Cancel this root x. Remaining is y is equal to here root 2 into root x, that is root 2 into x minus here also root x, here also root x, we get as x minus here we get only root 2. Root 2 into root 2 is 2, that is minus 2. Here minus into minus is plus. Root 2 into root x is root of 2x, which is equal to here root 2x plus root 2x, that is 2 into root 2x minus x minus 2. Next step we have to substitute y value and x value over here. We get as y is y square, which is equal to 2 into root of 2 into x is x square minus capital X is x square minus 2. Or we can take it as, if we take all this value to the left hand side, that becomes y square plus x square minus 2 into root 2x plus 2, which is equal to 0, is a singular solution for a given nonlinear differential equation. This completes the problem. We shall move on to another problem. Find general and singular solution for y square into y minus px, which is equal to x power 4 into p square by taking Clairaut's form using substitution. X is equal to 1 by x and y is equal to 1 by y. Here first take the given nonlinear differential equation, that is y square into y minus px, which is equal to x power 4 into p square. Call this as equation 1. Also take the substitution, that is x is equal to 1 by x and y is equal to 1 by y. Call this as equation 2 and this as equation 3. Next step, we have to differentiate this equation 2 with respect to x and equation 3 with respect to y. We get as dx by dx, which is equal to differentiation of 1 by x is minus 1 by x square. Dy by dy, which is equal to differentiation of 1 by y is minus 1 by y square. Next step, you know that p is equal to dy by dx, which is equal to dy by d into capital Y into d into capital Y by d into capital X into d into capital X by d into small x. If we cancel these terms, remaining is dy by dx itself. Substituting all this value, we get as here d into capital Y by d into small y is minus 1 by y square, but we want dy by d into capital Y. So if we reciprocate this value, we get as minus y square. That is minus y square into this value becomes capital P into dx by dx is minus 1 by x square. Therefore, we get a value of small letter p as here minus to minus becomes plus, that is p into y square by x square. Also we know that from equation 2 and equation 3, x is 1 by x and y is 1 by y. Here we have y square by x square. So in the place of y, substitute as 1 by capital Y divided by the place of capital X, substitute as 1 by capital X. We get as p is equal to capital P into x by y whole square. Next step, we have to substitute this p value in equation number 1. We get here y square is here capital Y is 1 by y. If we take this value to the left hand side, that is small letter y becomes 1 by capital Y. Y square is 1 by capital Y square into y is 1 by y minus small p is capital P into x by y whole square into small letter x is 1 by capital X, which is equal to small letter x power 4 is 1 by capital X power 4 into p square is capital P into x by y whole square whole power 2. Next step, take the squares here and simplify. We get as 1 by y square into 1 by y minus p into x square by y square into 1 by x, which is equal to 1 by x power 4 into p square into x power 4 by y power 4. Y square gets cancelled here. Here x square gets cancelled and here also 1x gets cancelled. Next remaining is here we can take in these two equations, we can take y square as LCM. We get as y square, if we take as LCM, y square by y is y minus here we have x into p divided by y square, which is equal to here remaining is p square divided by here y square is remaining, that is p square divided by y square. Here y square gets cancelled. We get as y minus xp, which is equal to p square. If we take this value to the right hand side, that becomes y is equal to xp plus p square. Observing this equation, this is a Clairaut's form of equation. Call this as equation 4. Next step, we have to find the general solution. For that, we have to substitute in the place of p as c, that is y is equal to cx plus c square. Next, we have to find a singular solution. For that, we have to differentiate this equation 4 partially with respect to capital P. We get in the left hand side, we get 0, which is equal to differentiation of p is 1, x is constant, take as it is, plus differentiation of p square is 2p, or we can take p value as minus x divided by 2. Here, if we take 2p is equal to minus x and 2 goes to the denominator, that becomes p is equal to minus x by 2. Also, we know that x is 1 by x and y is 1 by y. Substitute in the place of x as 1 by x, we get as minus 1 by 2x. That's the value of capital P. Next step, we have to substitute p value value and x and y value in equation number 4, we get here left hand side is y is 1 by y, which is equal to p is minus 1 by 2x into x is 1 by x plus into p square is minus 1 by 2x whole square. We get 1 by y, which is equal to here minus 1 by 2 into x square plus 1 by 4 into x square. In the right hand side, if we take 4x square as LCM, we get 1 by y, which is equal to minus 1 by 4x square. Here 4x square, take this to the left hand side and y to the right hand side. Finally, we get an equation as 4x square plus y, which is equal to 0, is a singular solution for a given nonlinear differential equation. This completes the problem. These are all some of the problems on Clairaut's form of equation and reducible to Clairaut's form of equation. In next video, we study about self-study topic in module 3. Hope you all understand and like the video. Thank you.